curved graph as another type of graph. Okay. Now in this curved graph we have different types of curved graph. We have the parallel or the parabola curved graph. We have the hyperbola curved graph. Then we can talk about the exponential curved graph. Alright, now for the first one there, we have it with this formula. Y is equal to this, where A, B, C are sort of constants. A, B, C, they are constants. Okay, so if we draw this graph, we are going to have the graph to be of this nature in different form. You see the one that can be curved in this way, in such a way it does not cut the x-axis. Okay, then you see the ones that can cut the x-axis must not be in this form, it can also be in this form. Okay, so when you consider this, you see that we have the maximum point here, and also for this we have the minimum point. Okay, alright, so in this case where we got this curve cuts the x-axis, we have that y is equal to what? To 0. Okay, that is the equation for the x-axis. Y is equal to what? 0. We said that before. Now, if that is the case, that means this equation here will reduce to ax squared plus bx plus c equal to what? 0. Then this is now a quadratic graph. Okay, this is a quadratic graph with the different roots for x. Alright, so then the other one is the hyperbola curve. Now for the hyperbola curved graph, we have it in such a way that the graph comes this way. Okay, as if it wants to cut the y-axis and also it wants to cut the x-axis. But nevertheless, it did not cut through. So in this type of graph, we have the equation to be equal to y equal to x c all over what? X. Okay, so that is the equation for this hyperbola curved graph. So we say that the y and x, they are asymptotic to each other. Okay, such that if x goes to 0 or is trying to go to 0, then we see that y will go to what? Infinity. And if y goes to infinity, then x will approach what? 0. So we say that this both x and y, they are asymptotic to what? To each other. Then the other type is the exponential kind of graph. Okay, so let's write that one here. So for the exponential type, we have that y is equal to c exponential minus kx. Here we have two constants, c and what? And k. Okay, there are the two constants that we have there, c and k. So if we look at this very well, it will give us a graph that will be of this nature, such that it will cut the y-axis and it will tend to cut the x-axis. So we have it this way. It's quite different from this one here. Here we have the graph to be in this form. It did not cut the y-axis, but here we have it to cut the what? The y-axis. Okay. So in this kind of graph, we call it the exponential type of graph. Okay. So you can see clearly that as y goes to 0, x goes to what? Infinity. But we can't say x goes to 0 and y goes to infinity. It's not true here because it cuts the what? The y-axis. So this shows that it is only asymptotic to what? To the x-axis. Alright. So this is just for the curved graph. So we are going to stop here for today. In our next class, we see how we can convert this curved graph and transform them to the linear graph or the straight line graph. You know, it is more easier to calculate with the linear or the straight line graph. Okay, you can easily calculate the intercept and also calculate the slope. But for the curved graph, the slope is changing at every point. Okay, so when you want to calculate the slope here, you tend to take the tangent at that what point. This tangent is a straight line that cuts that what point, so that we can form the shape of the triangle and get our x1, x2, y1, and also get your what y2. Then we can now calculate the slope. Okay. Now the other things, also the intercept and the rest of it, becomes very difficult to get from this point here. So from this curve graph. So in the next class, we are going to look at this transformation of this curved graph. So we discuss about the transformation of this curved graph. So we stop here for today. And thank you very much. Okay. So if you are new to the channel, you have not subscribed.